Hi dear students, I hope you have enjoyed my first video. We can go to the next video on chemical kinetics. If you have any doubts or any clarification, please message me in the link of YouTube video. I will find the time to attend your queries and doubts. Today, I am going to a different topics. The title is Rate of Change of Reactants, Products and Reaction. Obviously, you cannot see such a title in any textbooks. But I selected this title just because in my past experiences, many students have lack of clarity on rate of reactions and rate of change of reactants and products. Many have by hearted the methods and definition of rate of reactions. But when the question comes, connecting rate of change of reactants or products with the rate of reaction, such students fail. Their by hearted information could not help him to solve such questions. That is why I specifically selected this type of a title. Therefore, please watch the video till the end to get more clarity on these topics. And I will tell you one thing, this is one of the foundation of chemical kinetics. If this foundation is not clear, obviously your edifice, your chemical kinetics will collapse. When a tricky question, when a conceptual question comes in the question paper, particularly when you attempt any competitive examinations for JAM or any other test, IIT test, you will fail. Therefore, please watch it and clear the doubts and go ahead. We can go to the topics. This is the example I have taken. 2HI plus H2 gives H2 plus I2. A simple reaction. Suppose this is for HI. I have a bottle, a cup where HI has been taken. And these are the two bottles for H2 and I2. Imagine this situation. Suppose 2HI reacts. Why 2HI? Why I removed 2HI? Because the coefficient shows that 2. What is that 2? 2 moles. For convenience, we can take 2 molecules. Please, I request you, never think 2 molecules. Always think 2 moles. Whenever you take the molecular calculations, molecular counts should be 2 moles. 1 mole, half moles. When there is a half, my dear students, don't think that it is half of the molecules. Half of the atom. It is half moles. But for convenience, you think 2 moles. When 2 mole HI reacts, you will get 1 H2 and 1 I2. Again 2 moles. But you got 1 here, 1 here. What is happening here? The rate of change of rate of disappearance of HI is 2 per. 2 per, again 2. But 1. But rate of appearance of hydrogen is 1. 1 mole per unit time. I2 also 1 mole per unit time. But it is 2 mole per unit time. It is 1 mole per time. It is also 1 mole per time. My question is, the rate of change of Hi equal to rate of change of H2 or rate of change of I2? Tell me, is it equal? No. Rate of change of formation of products H2 or I2 is different from rate of disappearance or rate of change of Hi. What is this? In this reaction mixture, Hi plus H2 and I2, in this reaction mixture, you have a reactant Hi, two products H2 and I2, but when you look at their individual speed, they are different. That is, the participants, the individual speed of the participants are different. Therefore, we have three ideas, that is, individual speeds of reactants and products and rate of reactions. Fine? Rate of the reaction speed is a different idea. Suppose you have another reaction, H2 plus Cl2 gives 2HCl. Okay, you can compare speed of this reaction with this. That's an idea. But when you take this reaction along, there will be different reactants and different products. Their speeds are different. Okay, this is I am going to explain. And anyway, we can explain like this. Rate of change of Hi, rate of change of H2, rate of change of I2. Okay, this is minus dHI dt. This is dH2 by dt. This is di2 by dt. My dear students, you know why this negative sign? That has been explained in previous video. If you have not watched, please watch it and get the idea. And the derivative is just because of instantaneous rate. If you write down average rate, obviously you will get delta Hi by delta T. Delta H2 by delta T. Delta I2 by delta T. This is the individual average speed, this is the individual instantaneous speed. And this is my question. I have already asked the question. Is minus delta Hi, d delta Hi by dt equal to dH2 by dt? Is it equal? No. 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 Why no? Because this is our reaction. 2Hi gives H2 plus I2. In a given time, suppose 1 minute, 100 molecules of Hi reacts, only 50 molecules of H2 produced. Therefore, their speed is not equal. Now, the biggest question is, which will be taken as rate of reaction, rate of reaction, rate of reaction. Which one will be taken as rate of reaction? Whether it is rate of change of H2 or rate of change of I2 or rate of change of HI, which is the rate of reaction. In a reaction, different participants, that is different reactants and different products have different rate, then which will be selected as rate of reaction? Could you take this? Suppose Malavika takes this. Malavika takes this. She says that I2 is the rate of change of I2 is the rate of reaction. Khalil says rate of change of HI is the rate of reaction. Is it logical? No, because rate of chosen by Khalil is higher than rate chosen by Malavika. Therefore, then for a same reaction, you cannot have different rate. That is illogical, nonsense. Therefore, whenever if you choose any reactants or products, you should get same rate. That is a logical, that is a scientific. That will be possible when you get same rate whatever the reactants or products is chosen. This is possible when rate of reaction is expressed when rate of reaction is expressed as rate of change of 1 mole of any substance in given time. Fine. Therefore, rate of reaction will be expressed in terms of any reactants or products. Should be per mole. Therefore, please remember, this is the rate of change of HI. This is not for 1 mole, this is for 2 mole, because the coefficient has been given as 2 mole. Therefore, how could you make it 1 mole? Yes, divide by 1, multiply by 1 or divide by 2. That is why when you express the rate of reaction, the coefficient, if the coefficient is more than 1, it is written like this. Did you get the logic? Students, did you get the logic? Yes. If the coefficient is less than 1, greater than 1, it should be written. If it is less than 1 also, you should write like this. If it is 1 by 2, 1 by 1 by 2, 2 will come here. But in this case, you are lucky, you don't want to that because it's already 1. Now, all are correct. Rate of I2, rate of H2, rate of HI, all are correct. And all express rate of reaction, therefore, all are equal. Fine? Yes, this is the rate expression of this reaction. Suppose you have another reaction, suppose 5Br minus plus BrO3 minus plus 6H plus gives 3Br2 plus 3H2O. Suppose you have this type of a reaction. Yes, you have 5 participants. Its rate is different from this is different from this, and these are different. But what is the rate of reaction? Rate of reaction minus 1 by 5 dBr minus by dt. You know, minus 1 by 5? Yes, quite. You got that. This is the rate of, but what is this? It is the rate of change of Br minus, which is equal to dBr03 by dt, minus here, which is equal to 1 by 6 dH plus by dt, which is equal to 1 by 3 dBr2 by dt, which is equal to 1 by 3 dH2O by dt. Fine. What is this? This is a rate of change of H plus. This is a rate of change of Br2. This is a rate of change of H2. Therefore, the trick, please remember, rate of reaction will be equal to rate of change of reactants or products whose coefficient is 1. Rate of reaction will be equal to rate of change of reactants or products whose coefficient is 1. Therefore, to solve the question, I will tell you this is a trick. Please remember the trick. Suppose a reaction N2 plus 3H2 gives 2NH3. Okay. Individual rate. Suppose it is 1, 3. As compared, please remember, as compared to nitrogen, rate of change of hydrogen is 3 times greater. Fine. It is 2 times greater as compared to nitrogen. You compare with nitrogen. When you compare with nitrogen, rate of change of hydrogen is 3 times of its values. When you compare with nitrogen, rate of change of ammonia is, rate of formation of ammonia is 2 times. Therefore, I will tell you another very important idea. The coefficients of reactants and products in chemical kinetics gives you another idea. What is that idea? The idea is that how fast their rate of change happening. Therefore, please remember that you try to connect with any reactants or products whose coefficient is given as 1. Fine? Therefore, rate of reaction is equal to rate of change of nitrogen. But when you compare 1 by 3 of rate of change of hydrogen, it is 1 by 1. Rate of reaction is equal to rate of change of nitrogen. But when you compare with hydrogen, it is 1 by 3 of rate of change of hydrogen. It is 1 by 2 times of rate of change of ammonia. Therefore, this is a trick. You compare with any reactants or products whose coefficient is 1. And please remember this point also. If you know rate of change of any reactant or products, you can calculate rate of change of all others. If you know rate of change of any reactants or products, you can calculate rate of change of all others. And as well as you can calculate rate of reaction also. Okay? But the condition, you should get a balanced equation. Because coefficient tells you a different idea. Coefficient tells you one more idea, that the individual rate of each reactants and products. Let us solve a question. Please solve this question. Consider the reaction N2 plus 3H2 gives 2NH3. If the rate of formation of ammonia is 0.5 into 10 raised minus 2 mole liter raised minus 1 per second. Calculate rate of disappearance of H2 and rate of reaction. you have been given rate of formation of ammonia. That is, this is a rate 0.5 into 10 raised to minus 2. What is the rate of disappearance of H2 and rate of reaction? Therefore, this is our trick. If you know all the idea, it's very, very simple. Very simple. If you know the idea, this is a balanced equation. Here the coefficient is 2. Therefore, rate of reaction is equal to 1 by 2 of rate of change of ammonia. Rate of change of ammonia. That is 1 by 2 into 0.5 into 10 raised to minus 2 mole liter raised to minus 1 second. That is 0.25 into 10 raised to minus 2 mole liter raised to minus 1 second. Very simple. Very simple. Now, if you know the rate of reaction for per mole, 1 mole, you can calculate the rate of change of every other substance. Okay, the rate of reaction is known. What is the number here? Because you know rate of reaction is equal to 1 by 3 into rate of change of H2. Therefore, what rate of change of H2 or rate of disappearance of H2 is equal to, you multiply 3 here, that is 3 into rate of reaction. What is that? 0.25 into 10 raised to minus 2 mole liter raised to minus 1 second raised to minus 1. That is 0.75 into 10 raised to minus 2 mole liter raised to minus 1 second raised to minus 1. This is the answer. Very simple. Do you have any doubt? No. Okay. You do one homework. Please finish the homework and share me the answer. Any doubts, you can clear it. This is the homework. Please do that. Consider the decomposition. Consider the decomposition of N2O5. That is N2O5 gives 2NO2 plus O2. NO2 plus 2N2O5 plus 4NO2 plus O2. Okay, 8, 10. The concentration of N2O5 changes from 0.84 mole liter raised to minus 1 to 0.54 mole liter raised to minus 1 in 180 seconds. Okay, concentration change. What is the average rate of formation of NO2 and average rate of reaction? Okay, don't confuse with the word average, whether it is average or disappearance. The trick and idea is easy. Please solve this, get the answer. If you find any difficulty, don't hesitate to contact me. I hope you have enjoyed this video. You finished it. Thank you for watching. Thank you. Have a nice day.